Have you ever woken up from a dream and thought, whoa, where did that come from? Maybe you were flying over your school, or perhaps your pet cat was giving you advice about your homework. It can feel pretty strange, right? Those bizarre adventures are a fascinating part of being human. They're like a secret movie that your brain directs, produces, and stars in every single night, all for an audience of one. You. These nightly features can be exciting, scary, or just plain weird. But they aren't just random nonsense. There's some serious science happening inside your head while you're catching those Z's, and we're going to explore it together. So, what exactly is a dream? Think of it as a collection of thoughts, images, and feelings that happen when you're asleep. They can be incredibly vivid. You might smell the popcorn at a phantom movie theater, or feel the wind as you soar through the sky. These experiences are created entirely by your brain, using bits and pieces of your day, your memories, your worries, and your hopes. It's your mind's way of sorting through all the information it has collected. It's a bit like cleaning up your room, but instead of socks and toys, your brain is organizing memories and emotions. Dreams are a universal human experience. That means everyone, all around the world, does it. From the moment we are tiny babies, our brains are busy dreaming away. Even people who say they don't dream actually do. They just don't remember their dreams when they wake up. It's like watching a fantastic movie, but forgetting the plot the second the credits roll. These internal stories are a fundamental part of how our brains work, a built-in feature that has puzzled and fascinated people for thousands of years. But today, thanks to science, we're starting to pull back the curtain on this amazing nightly spectacle. To understand dreams, we first need to talk about sleep. Sleep isn't just one long, quiet nap. Your brain actually goes through a cycle of different stages all night long. Think of it like levels in a video game. You start in the lighter stages and gradually go deeper and deeper into sleep. But the real magic happens in a special stage called REM sleep. REM stands for rapid eye movement. It's called that because during this stage, your eyes dart back and forth quickly behind your closed eyelids, as if you're watching a super fast tennis match. This is when your most vivid, story-like dreams usually occur. During REM sleep, your brain becomes incredibly active, almost as active as when you're awake. All the parts of your brain responsible for learning, thinking, and feeling light up. At the same time, your brain sends a signal down to your spinal cord that temporarily paralyzes most of your muscles. This is a very important safety feature. It's called muscle atonia, and it prevents you from physically acting out your dreams. Imagine dreaming you're a superhero flying off the couch. This clever switch keeps you safely tucked in bed instead of attempting to launch yourself across the living room. It's your brain's own built-in safety harness. You cycle through these sleep stages several times a night, with each REM period getting a little bit longer. Your first REM cycle might only last about 10 minutes, but by the end of the night, you could be dreaming for up to an hour at a time. This is why you're most likely to remember a dream if you wake up in the morning, right as a long REM session is finishing. It's like catching the grand finale of your brain's nightly movie marathon. All told, the average person spends about 2 hours dreaming every single night. That adds up to about 6 full years of dreaming over an average lifetime. So, REM sleep is the main stage for our big, blockbuster dreams. It's when our brain gets to be the most creative, the most emotional, and the most active, all while our bodies stay still and recharge. It's a perfectly designed system that allows us to explore incredible worlds without ever leaving our beds. So how do we know all this stuff about REM sleep and brain activity? We can't just ask a sleeping person what's happening in their head. This is where science gets really clever. Scientists who study sleep, called somnologists, act like detectives. They use special tools to gather clues from the sleeping brain. One of the most important tools is an electroencephalogram, or EEG. That's a big word, but the idea is simple. Scientists place small sensors, called electrodes, on a person's scalp. These sensors can listen in on the tiny electrical signals that brain cells use to talk to each other. By looking at the patterns on the EEG, scientists can tell exactly which stage of sleep a person is in. The brain waves during deep sleep are long and slow, but during REM sleep, they become fast and jagged, looking very similar to the brainwaves of someone who is wide awake and solving a math problem. To get even more clues, scientists also use sensors to track eye movements, which show the rapid eye movement of REM and muscle activity, which shows that safety switch paralysis we talked about. Putting all this data together gives them a complete picture of what's happening during the night. Sometimes the best way to study dreams is to wake people up. In sleep labs, researchers will watch the monitors, and when they see that a person has entered REM sleep, they'll gently wake them up and ask, "What were you just dreaming about?" By doing this over and over, they can connect the brain activity they see on the screen with the dream stories people report. For instance, they've found that the parts of the brain involved in seeing, hearing, and feeling emotions are super active during dreams, which is why dreams can feel so incredibly real and emotionally charged. This detective work has led to some amazing discoveries. It's through these careful investigations that we've begun to piece together the science behind our nightly adventures. Okay, so we know when and how we dream, but the million-dollar question is, why? Why does our brain spend so much time and energy creating these nightly stories? Scientists don't have one single answer, but they have some really great theories. Think of it like a group of detectives each having their own idea about who committed the crime. One major theory is that dreams are crucial for memory consolidation. During the day, you learn so many new things. At night, your brain is like a librarian, sorting through all those new books of information, deciding which ones to keep and where to put them on the shelves for long-term storage. Another popular idea is that dreams are a way for us to process our emotions. Imagine you had a tough day at school or an argument with a friend. Your dream might act like a safe playground where you can work through those feelings without real-world consequences. It's a kind of nightly therapy session. By replaying emotional events in a dream state, your brain can strip away some of the stress, helping you feel better and more prepared to handle the situation in the future. Then there's the creativity theory. Some scientists believe that dreams are a source of problem-solving and inspiration. Because the logical part of your brain is less active, your mind is free to make connections between ideas that it wouldn't normally make when you're awake. This can lead to incredible aha moments. Many famous artists, musicians, and scientists have claimed that their best ideas came to them in a dream. Finally, there's the threat simulation theory. This one sounds a little intense, but it makes sense from an evolutionary perspective. This theory suggests that dreams are a safe place to practice for dangerous situations. Dreaming about being chased or facing a challenge could be your brain's way of running a fire drill. It lets you rehearse your fight or flight responses so that if you ever face a real threat, you'll be quicker and better prepared to react. Each of these theories likely holds a piece of the puzzle, and dreaming might just do all of these things at once. Now for the really fun stuff. The world of dreams is filled with bizarre facts. They show how creative and strange our brains can be. For example, did you know that you can't read or tell time in most dreams? If you look at a clock in a dream, the time will likely be blurry, or it will change every time you look again. The parts of our brain for understanding language and for linear time are less active, so these concepts get jumbled. It's one of the classic movie ways people realize they're dreaming. Here's another surprise. We often dream in black and white. Many dreams are full, vivid color, but studies show lots of people report monochrome dreams like an old movie. People who grew up with black and white TV dream in grayscale more often, while younger viewers raised on color TV tend to dream in color. Media we consume can influence the visual style of our dreams. Your brain is a director. It takes inspiration from movies and from shows you watch. Despite our scientific progress, so much about dreaming remains mysterious. We still don't know if animals dream in story-like ways like humans do, although we see them twitch and make noises in their sleep. We also don't fully understand recurring dreams, the same dream over and over. And the biggest mystery of all, what is consciousness? How does our brain create rich internal worlds from electrical signals? The science of dreams is a frontier being explored. So keep being curious. The universe is full of amazing puzzles. The world inside your mind is one of the greatest. Pay attention to your dreams, ask questions, and never stop exploring the science around us and inside us. Science is for everyone. It helps us understand ourselves and our world in incredible ways. Thanks for exploring with me. If you enjoyed our journey, be sure to hit that like button and subscribe for more science adventures.